And going to start into something called analysis of covariance, ANCOVA for short. And what I want you to think about is we start with the ANOVA techniques, and if we squeeze in a C right there, we have a technique called ANCOVA, again, analysis of covariance. Now, let's pump the brakes a little bit and think about what is meant by covariance and variance, and in a sense, correlation. Covariance is a statistical technique denoted by COV, and let's say the two variables x comma y, where we just examine the relationship between the two variables using the units of the study of the measurements. Compare this to variance, where we're just looking at how a particular variable itself varies around the mean. Correlation is very related to covariance, except correlation standardizes your x and standardizes your y and kind of looks at the covariance between the z-scores for each. So just not something that's really going to take much meaning or emphasis in studying ANCOVA, but just wanted to pump the brakes for a second and revisit that. Now, where does the ANCOVA procedure lie? So if we think about our dependent variable, which can be either quantitative or categorical, I wish I could keep that from jumping around. Maybe if I don't put my hand there, it will. All right. And then our predictor could be either categorical. So this would be our X, right? So the independent variable could be categorical or quantitative. So if we have a categorical variable that we're examining with another categorical variable, we should know by now we use chi-square techniques. If we have a quantitative dependent variable over a categorical variable, we use ANOVA techniques. Now, again, if the categorical variable has two levels, we would use like an independent samples t-test. But if it has three, we move into ANOVA. Now that we're going to get kind of relax that to a point where even if our categorical variable has only two levels, we're going to often reside in the ANOVA family. Now, if our independent variable is quantitative, then we get into the logistic regression world. If the dependent variables categorical and binary. So in other words, one of two outcomes. If it gets into something more than binary, say we have three levels or four levels for the dependent variable, we get into something called discriminant function analysis. And then if we have a quantitative dependent and a quantitative independent, then we get into regression correlation techniques. So what are we going to do here? We're going to do a focus on ANCOVA. So ANCOVA, again, I want you to think about it as using standard ANOVA techniques, but then we have a reason to believe within the goals of our study to add a quantitative variable as what we call a covariate. So again, standard stuff. We have a y, which is a dependent variable. We have an x, which is an independent variable that is categorical. And then we have this additional quantitative variable that seems to explain some of the unexplained variance. I was teaching a grad level class the other day to occupational therapy. I'm kind of a guest speaker to their research class every year, and I teach for two weeks. I teach kind of an intro to quantitative analysis for their research. And a student asked me, said, just exactly what is a covariate? It's kind of hard to define. So I just say that a covariate is just an additional variable, which is quantitative, that is some way related to the dependent variable. The primary reason, tattoo this one to the brain, is to reduce error variance. And we can also use it to increase experimental control. But again, when I think of a covariate added to an ANOVA design, I think about reducing error variance. Now, what do I mean by that? Well, anytime we run a model, we've got variance that is explained versus variance that is unexplained. And our test statistic is the ratio of the two, the ratio of the explained variance to the unexplained variance. And obviously, as the ratio gets higher, we have a higher percentage of, or the ratio of explained to unexplained is higher. Well, if we think about this unexplained variance, there may be this kind of lurking variable there uh, that, again, is quantitative, that may reduce some of this unexplained variance. So when this happens, when we add the covariant to the model, then we can think of this part all becoming explained variance. So the only part that is unexplained would be this small piece of the pie that remains. So again, primary reason to add a covariate, reduce the error variance. Now, just to give you a little a graphic on this, we take the total sum of squares, partition it into two sources of variance, the sum of squares for our model and the sum of squares for our error. We can take the sum of squares for the error and partition it into two um, pieces of variance, the covariate piece and the error piece, and this becomes part of the explained variance. Now, let's move into an example. So let's say we're focusing on evaluating types of instruction. And let's just say, to make maybe this more meaningful, maybe we have three teachers, teacher one, teacher two, teacher three. And I want to keep the sample size small here for obvious reasons. And we want to give a teaching award to the quote unquote best teacher. So we give the ACT at the end of each class, and we see that instructor number one, their students did relatively well. They had a mean of 26 with a standard deviation of 2. Instructor number two did exceptionally well. Their students had a 34, 35, 35 with an average of 34.67. And instructor number three had a average of 21. Now, based on this information, who should get the teaching award? Well, clearly this instructor here, right? And again, based solely on ACT score, you would think that this particular instructor did a poorer job than these two. Well, we know there's more to the story, obviously. So let's assume that we have some additional information. Let's say that we have a pre-ACT score. So we have the ACT score before the student came into the class, and then we have the ACT score when the student completed the class with instructor one, instructor two, and instructor three. Well, this instructor had an average gain of 2.7. This student did very well, right? Increased their ACT from 23 to 28. This instructor just happened to have a bunch of really bright students, if you believe, quote unquote, bright can be measured by the ACT. And there just wasn't a lot of gain there, right? Their ACT scores, the post ACT scores, were extremely high because there wasn't really a lot of work to do because you had a bunch of bright students. There are, let me be careful with this one. Let's just say there are college professors around the country that in order for you to, for them to think that you're prepared to take their Calc 1 class, you should have completed Calc 4. Sorry about that, a little bit of a tangent. And this instructor 3 started out with 16, 18, 20, and they had quite a bit of. So when we look at it this way, who should probably receive the award? Well, I tell you what, based on this alone, I would think that instructor 3, because the instruction component, we are better to identify that treatment when we control for the entering achievement level. Again, well, I think this is pretty clear, and I don't think it needs much more narrative. So I think it'd be really close. Now, um, you know, this person had no way to get an average of 3. Uh, I guess that person could have scored a 36. I don't think you can score a 37. I don't think you can score a 38. So in terms of uh, uh, receiving the teaching award, I don't think that instructor two had a prayer of that. And we see that a lot, really, like in NCAA basketball, right? Think about it. What um, basketball coach typically gets Coach of the Year? Is it the Caliparis and the Coach K's and those who have all the 5 stars? And they win it from time to time, but they typically win it when they don't have all the 5 stars, but they've developed some 3 and 4 stars or had some injuries or something like that. Um, Sorry about that. Just a little sport add on. So, if the covariate and Y, uh, let's see, I just don't like the way this thing is. Okay, that seems to be clear. And I think if I leave my hand out there, I think it'll be a little bit more stable. So if the covariate and the Y, which is your dependent variable, are on the same measurement, then you may consider a dependent samples t-test. But to develop the study in terms of getting into treatment effects and with multiple layers, then that's the reason we bring in uh, ANCOVA techniques. All right, a couple of examples. What would be possible covariate? Let's say that we're examining self-reported depression scale over gender. Well, I think obviously a possible covariate would be some initial level of depression. Let's say we're examining salaries of men and women in a corporation. Well, I think I would want to come in and take a look at the number of years since completing college. I think that would explain some of the variance in salaries across men and women. And that's a very these studies. I will tell you, I'm not going to get into it much, but these studies are very, very complex when you look at examine the salaries of men and women. Um, Weight gain, loss over type of diet. Say we have diet 1, diet 2, diet 3, whatever, however many levels of diet. I would think that the initial weight is something that we would want to include as a covariate. So what if our covariate is categorical? So we have a score on a calculus final exam, and X is the type of instruction, remote, blended, or face-to-face. Maybe the ugliest F in the history of the English alphabet. Uh, what if our covariate we want to control for is grade in pre-calc, and we've dichotomized that as C or higher, or C minus or lower? Is this a covariate? A lot of debate on that, a lot of discussion out there about this. I think no, I think it's not. I think we call that a control variable, but to me, a covariate is always a quantitative. Now, what if the grade in the pre-calc was maybe the final exam score in pre-calc, 82%, 78%, then it's quantitative? Then I think that is a classic covariate and something that we may want. Again, the focus of the study is not really the calculus final exam. This is just a measurement that we're using to help us examine the treatment effect, which level, which type of instruction. So we in ANOVA techniques, you have to kind of restructure the way you think. This is just a measurement that helps us examine differences here. So this is really where the focus is on the independent variable, and the covariate would help us reduce the error variance. All right, not much more. So how do I want you to think about ANCOVA? I want you to think about it sequentially. Think about we conduct an ANOVA, where again we examine group means for some quantitative dependent variable y across some levels of x. And then we add into it. We know that out there somewhere there's this covariate, this quantitative variable that's related to y, that may explain some of the variance that allows us to better focus on the categorical variable. So we add as the third step this covariate to the ANOVA to examine the impact of the treatment effects when we add in the covariate. That's when we have an ANCOVA design. So again, I don't want you to ever think about, well, I'm just going to do ANCOVA. All right, well, cool. Again, run your ANOVA first, then defend adding your covariate, test your assumptions and all that, and then examine your model in terms of the impact of the covariate as it has been added. All right, speaking of assumptions, what are the assumptions for the model? What are, as you would expect, they're the same as ANOVA: independence, equivariance, and normality. But we have two additional assumptions that we have to test. The first assumption is independence of the covariate and the treatments. Now, again, the treatments here, x1, x2, and that's really easy to do. We just run an ANOVA where our dependent variable is the covariate, because again, it's quantitative, across the treatments, x1, x2, x3, whatever it may be. And we want a non-statistically significant result. I'll explain all that and demonstrate it in the next video. The next thing we want is we need homogeneity of regression slopes. So the way we take a look at this is we look at our covariate. Our covariate is considered, in this case, to be the independent variable. And our dependent variable y is still the deepest, plays the role of the dependent variable in this analysis. And then what we do for each of our independent levels, we create a regression model. And we want to eyeball this and test that these regression slopes are the same. Now, if I add in an x4 and it looks like this, then I have a violation of the homogeneity of regression slopes. And, what do we do when that happens? Well, that's where the fun starts. All right, so we'll cross that bridge when we get there. All right, gang, that's all I got.